Hello class, and hello a second time for some that already watched the classifying triangles video. So we have another short video, and this video is on isosceles triangles. Okay, and you should already know what an isosceles triangle is. And an isosceles triangle is a triangle that has at least two sides congruent. And what we need to be able to do with the isosceles triangle is label it correctly. So the first thing that needs to be labeled is the sides that are congruent. And you can tell in this picture that I've labeled these as the congruent sides. So the congruent sides are what we call the legs. And the side that is not have the tick mark on it is what we call the base. And then it kind of makes it easy to label. We have three angles, and if you see here, I have a shaded blue angle, and then I have two red angles. The shaded blue angle, which is the angle that just kind of sits between the two legs, where the legs intersect, that's called my vertex angle. And then the other two angles, which sit here and here, which sit along the base, are what I call my base angles, so they're very easy to name. What you have to understand about an isosceles triangle is that, remember, there's a relationship between legs being congruent and angles. So if the legs are congruent, then the angles are congruent. And the same would go for the converse, that if the angles are congruent, the legs are congruent. So why don't we just write that down real quick? So if legs are congruent, then base angles are congruent. And then obviously the converse will also work. So if, remember, base angles then legs are congruent. So depending on the drawing, I can either put that the legs are congruent and then therefore the angles are congruent, or I could just mark the angles congruent in the picture and then you would know it's an isosceles triangle. But I know this seems fast, guys, but it is very important, and you will be tested on the parts of the isosceles triangle. So you will need to know that these are the legs. The part that are not congruent is called the base. The angles that lie along that are called the base angles. And the angle at the top is called the vertex angle. So the next 7 slides are literally just algebra or math problems that deal with isosceles triangles. So after a couple of times, I'd like you to pause the video when you come to the problem and try the problem on your own. Otherwise, you're not going to learn or attempt to do them on your own. So when I come to this problem, the first thing I realize is that it's isosceles. So I say to myself, well, if the legs are congruent, then the base angles are congruent. And so I can come here and say this is my vertex, because that's where my legs touch, which means these are my base. So x in this case is 68 degrees, which is very easy. And then I ask myself, well, how do I find y? Well, what type of angle pair are x and y? Linear. They form a line. So all I'm going to do is take 180 and subtract 68, and my answer is that y equals 112 degrees. And that's it. Let's look at the next one. So in this picture, I have a large isosceles triangle that I want to take note to, and then I have right here a right triangle. So if I wanted to, I know the triangle interior sum theorem, which tells me that 180 minus 90 minus 52 will give me 38. But you have no reason yet to know that, because this is 38, this is 38. But if this is 90, this is 90, because these are linear. But how do I get y? Well, if I look at this, this is one large isosceles triangle. So this and this would be the base angles. So y is 52 degrees. So if I put 52 here, then I could do 90, 52, and then I know this is 38. So x is 38, but you don't know, or if you needed to justify why, you'd have to say because isosceles triangle proves that this is 52. So why don't you take a second, think about what you would do here. And then hopefully you realize that this is isosceles. This is a leg, and this is a leg. Where the legs meet is the vertex. So this is the vertex angle, which means these are base angles. And if these are base angles, it means they are congruent. So go ahead and solve this problem, please. Pause the video. And then hopefully you realize that x is 9. As you can see, most of these are pretty easy. I can't ask too much with isosceles triangle. So here's a very, very common, popular isosceles triangle problem in which I give you an angle. What angle is this? Well, if again I do a little trace of my legs, here are my legs, where they meet is the vertex. So if I give you the vertex, I then know if you wanted to, if this is x, I could put x here. So for those that like the triangle sum theorem, I could do 180 has to equal 82 plus x. Or for those that can pick it up, I can take 180 and subtract 82 and realize there's 98 degrees left, which is exactly what you're going to do here. So you're going to subtract 82 and you're going to get 98 equals 2x, and then all we need to do is divide by 2, and x is 49 degrees. Okay. So with that similar concept from the last two problems, I want you to definitely pause the video and attempt this problem on your own. Pause the video. Don't cheat. Okay, so hopefully you realize that these are the legs here. This is a leg and this is a leg, so where the legs meet is the vertex. So this angle is the vertex. But again, this is a problem in which I have two x's and one y. So I have to do something with x's first. Well, these are the base angles. So if these are the base angles, they're congruent. If they are congruent, I set them equal, and x is 9. Well, in order to get back to get a value for y, I need to plug back in what I got for x. So when I take 9, I get 9 times 9, which is 81, and 81 minus 13 gives me 68. So this is 68, which makes this 68, and then I could either set 68 plus 4y equal to 180, or I can subtract 68 and 68 from 180 and realize that 4y has to equal 44. So 4y is 44 and y is 11. Okay. Next problem, for those that kind of like a puzzle, this is just the concepts of triangle sum theorem, isosceles triangle, right triangle, whatever you need to do. So why don't you pause and see which ones you can come up with on your own first, and if you get stuck, then refer back to me. So the first spot I start is that there's a little isosceles triangle down here. And if there's a little isosceles triangle down here and I have a value, which I have the vertex, then I know 180 minus that vertex gives me 116. So I know there's 116 left, and if I wanted to, I could put an x here. So it's going to be 116 equals 2x, and x is 58. So I know this is 58 degrees. I now know down here is 58 degrees. Well, there's a couple ways. That's why I wanted you to do this problem on your own, because there is a few ways to do this. This is a linear pair right here. So if this is 164, I could put 116 here. I now am in a triangle here, but I only have one value. But if you look at this large right triangle, the large one, I know that this corner is 58. I know this corner is 90. And so I could take 180 minus 90 minus 58 to get y. So then y ends up being 32 degrees. And then once that's 32 degrees, I could take 180 minus 116 minus 32 to get z. Or, since z is part of this 90 degrees, I could also take 90 minus 58 to get z, and z is 32. So hopefully you did this by yourself and got some or all. And then we have one more problem, in which, again, I'd like you to pause, try it on your own, see what you can come up with before coming back to me. So again, in this problem, if I start with the vertex here, which is 24, I'm going to take 180 minus 24. I'm going to take 180 and I'm going to subtract 24. I'm going to get 156, which means that's what's left in this triangle. But I know that technically this, I don't want to call it x because there's already an x in my problem, that this y and this y have to be the same. So if I take 156 and divide it by 2, I get that each of these corners are 78. So I'm going to put 78 here. Now remember, this is not in here. This is exterior to that. So if that's exterior to this, remember, what does an interior and exterior always have to add up to? 180. So you could either make this 102 and set 2x minus 18 equal to 102, or you could have wrote it as 78 plus 2x minus 18 equals 180, however you want. Then I add 18, and 2x equals 120, and x is 60 degrees. And that's all my problem asked for, was the value of x. Okay, so there's some isosceles triangle problems. If you have some extra time in the station, I'd like you to look at worksheet 4.7, and I'd like you to practice problems 1 through 4. All right, thanks.